Okay, let's talk about this. So, in my experience, the thing that students seem to love most when I write on the board is when I start something like this topic with the word simply. So I'm going to do it anyway, and we'll see how we go. We simply need to solve AX equals B to find a general solution, where A is a square matrix coefficients, X is the variable column matrix, and B is a solution column matrix, and this is how we do it. So it's actually, in terms of an equation, it's pretty easy, except we just have to remember we can't divide by A. We can't divide by matrices. Instead, we define it as multiplying by the inverse, which creates the identity matrices, and that's how we solve these problems, and we have to make sure we get our multiplication on the right side. So I've got an example here. You'll note we can't invert a non-square by square matrix, but there are ways of solving systems of equations where you don't have a square by square coefficient matrix. So here we do, we've got A, B and C and we've got 3 equations, so this works, but we might have 4 coefficients and only 3 equations, in which case there's probably going to be an infinite number of solutions. We can solve that either by creating a zero matrix and then using that to make it a square by square. No, I'm sorry, a square matrix with a row of zeros at the bottom, so a zero equation. Or we can use some different methods, but you won't have to worry about that. I'll only be giving you 2 by 2 or 3 by 3, maybe 4 by 4, but then 3 by 3 and 4 by 4 you can depend on technology more. So we're going to solve example 5 by first defining A as 2, -1, 1, and then 1, 3, -1, and then 0, no that's not right, 4, 0, 3. So the B is the term that's missing in that third one, so I have to make sure that I lose the B. My X matrix, which is my variable matrix, is A, B, C, and my B matrix, which is my solution matrix, is 6, 27, 22. Does anyone know the inverse of 2, -1, 1, etc., of matrix A? Does anyone know an easy way of finding it? So at this stage we can rely on technology. We can find that, but to find the inverse, A inverse would be equal to some matrix where you'd call the cells A11, A12, A13, ... and it would be such that when you multiply this by A, it would be equal to I. So we could set up A, we could set up I, and then we could find A inverse by expanding those out and equating each of the terms, but we end up with 9 equations to solve for 9 things. There is a 0 in there in the second column, third row, which makes things a bit easier, but it's going to get a bit out of hand. So instead we can depend on technology. So how do we do this with technology? We could do. We can actually just find the inverse. That's not what I wanted to do. What are you doing? So we can find a determinant. So we've got a method for finding the determinant of a 3 by 3.
Yeah, but then what do you do with the rest?
But we don't know the generalisation for how to apply that determinant to get the inverse. So instead we'll just use the technology here.
Is there such?
There is, but it's a bit complex, and you don't need to know it. So you can look it up by all means. I'm just going to get this up and we'll do it this way. Okay, what do you got here? Run matrix. Execute, there we go. And we want to create a matrix. So that's not the right one, is it? No, I don't want to define it. I'm happy not to do that. So if I go into math, there is a matrix vector tool here. I can create a 3 by 3. My 3 by 3 will be 2, -1, 1, 1, 3, -1, 2, oops. So 2, -1, 1, 1, 3, -1, and then 4, 0, 3, was it? Didn't go across. And if I go outside here, I can raise that with this button here to the power of -1, and it will give me my inverse matrix here. Was it, what was it?
Wasn't it 404? If you count something by...
No, it's 403. Don't do that to me. I've already done the calculation.
Inverse?
So say that again.
If you times something by the negative identity, will it become that form?
It'll become the negative inverse, yeah.
I don't know if that's mine.
Because if you times it by the negative matrix, you can make it multiplied by the matrix with a -1 scalar. And then that -1 scalar can hold, it'll be outside the identity, and then you get that value there. Okay, so there's my matrix, and I'm going to, can I make this bigger so I can actually see it? Calculator screen, large 3. That's not the calculator screen.
What?
What is it?
It doesn't make it bigger anyway. Oh, there we go. That's what I want. Okay.
What is it?
So there's my inverse matrix. And what do I do with that inverse matrix? Times it by B. Excellent. So X will be equal to A inverse B, which will be equal to 9/13, 3/13, -2/13, -7/13, 2/13, 3/13, -12/13, -4/13, and 7/13. What do you think the determinant might be of A inverse? Out of interest? It's probably 13.
1 over 13.
It's probably 13 because normally we multiply by 1 over the determinant, don't we? So we could check that. But you'll notice here that the numerators of all those don't match any of the numerators in our calculation up above. So it's a bit of a mismatch and makes it a bit harder to calculate. Anyway, B is this, 6, 27, 22. We're relying on technology and that's okay for a 3 by 3. So now I can go back down to here. I shouldn't have made it all so big. Let's make it normal again. And I'm going to do answer times by, and I'm going to create another matrix here. So this one will be a 3 by 1. And what was it? 6, 27, 21, 22? 6, 27, 22.
Oh!
Wow.
Whoa.
Whoa.
What intonation?
Does it really?
No, it doesn't seem right.
No, it doesn't feel right to me either. It's definitely A inverse.
I think you have to make the matrices.
Yeah.
So,
I remember when you used answer last time, it didn't work.
oh, that'd be annoying. But I don't want to type out that whole matrix here.
I'm not sure.
What is it? Tom?
Okay, let's do this instead. What was my initial matrix here? Did anybody write it down?
Wait. 6, -2.
2, -1, 1.
1, 3, -1, 4 over 3.
Don't get too far ahead of me, Xander.
It's -1.
You've made me rush.
So you made 11.
It's really, my computer for some reason this morning is really laggy. 1, 3, -1.
No, you're not inverse. Look.
4 over 3, 4 over 3, 4 over 3.
Hey.
Oh, 3. That's 2.
You did 2, though.
Oh.
I fixed it. Okay, raise that to the power of -1. Let's see if this works.
7, 6, -2.
That's confusing.
Yeah. Don't know why it does that. I'll have a look at it and I'll see if I can work out why it does that. 7, 6, -2 makes more sense.
Oh, matrix the answer maybe?
7, 6, -2 for A equals 7, B equals 6, C equals -2. Have we got an easy way of checking this? I'll just be a second, Chris.
AX times B. Do we just times A by that and see if it equals B?
I was thinking more along the lines of technology. You've got a simultaneous equation solver in your graphics calculator. So you could easily do that just to check you get the right answer. You've done things right, particularly when you get something like 0, 0, 0 for some reason. So just keep that in mind. Or you could put those numbers back in to see if it works. So 2a minus b is 14, minus 6 is 8, plus negative 2 is 6. That works. And example 6, but I'm going to just leave you to have a play with that for a minute.